In this video, we are going to look at how to calculate the future value of an annuity. Finite means that the payments occur for some fixed amount of time or not through infinity. Equal payments are those that are all the same. And a regular interval just means that it occurs with some consistent frequencies. For example, every year, every 6 months, every 14 days. There are two main types, and one of them is an ordinary annuity, and that means that the payment will occur at the end of the time period, the end of the month, the end of the quarter, the end of the year. Another type of annuity is an annuity due, and that's when we shift the payments to the beginning of the time period. Here you see our variables, and our first variable is going to be time, and that's going to be the number of years multiplied by the number of time periods in a year. And so over the course of our annuity, that's going to be the number of time periods. So if we save every month, then the time periods would be the number of months that we're saving for. Our interest rate is going to be some periodic rate, and it's going to be an annual rate divided by the number of time periods in a year. So for example, if we had 12% as an annual rate and we were looking at quarterly compounding, we would divide 12% by 4 to get 3% per quarter. Our present value is going to be the cash flow at time 0. It's going to be the price today. Our payment is going to be the annuity. It's going to be the finite series of equal payments that occur at regular intervals. That is going to be our annuity amount. Normally in the formula or the equation, we would abbreviate it as PMT for payment. It's also possible you could see it as a C or CF for cash flow. In the case of bond payments, it might be abbreviated as INT for the interest payment or coupon. And then a future value is going to be some cash flow in the future or a value of cash flows at some point in the future. And so let's look at an example. Assume you would like to retire in 40 years. You are able to save $4,000 at the end of each of the next 40 years. So in this case, we're going to have a series of equal payments. They're all going to be $4,000. They're going to be for some finite period of time, in this case 40 years. And they're going to occur at regular intervals at the end of each of the next 40 years. So in this case, we have an annuity. If you were able to earn 7% per year with annual compounding, how much would you have at retirement? And so here we see our equation, where our future value is going to be equal to our payment or PMT, which is our annuity, times the quantity that we would call our future value interest factor of an annuity. And that is the quantity of 1 plus r to the t minus 1 all over r. One important thing to note when you're working out these calculations is to make sure that divisor bar does not disappear as you write out additional iterations of the formula. In other words, what can happen is you can start to trail off on the way that you're writing that formula, and then eventually you'll get a different or wrong equation. So let's look at our inputs here. Our PMT is going to be $4,000. Our T is going to be 40, or 40 times 1, and we again use 40 times 1 because there is 1 year in a year. Our R is going to be 7% divided by 1, or 0.07 divided by 1. Again, because we have to get a periodic rate, but in this case we're dealing with years, and so we just divide by 1. So here we see our setup with our inputs on the right. And we get our future value is equal to $4,000 times the quantity of 1 plus 0.07 raised to the 40th power minus 1, all over 0.07. And we'll continue to work this out to where we get a future value is equal to $4,000 times 199.635112. And in this case, we get a future value of $798,540 and about 45 cents. This means that if you were able to save $4,000 at the end of each of the next 40 years, and earn 7% per year until retirement on all of the money that you have saved. At the end of the 40th year, you would have $798,540 and about 45 cents. Here we can see the power of compounding. In this case, you've only invested $4,000 for 40 years. In other words, you've contributed $160,000 into retirement. Because you earn interest every year on the investments that you have saved, you were able to have nearly $800,000 at retirement. So you'll have almost $640,000 extra in retirement based on interest after saving for this 40 years. And here we see another example. And in this case, we're going to change how often we invest and how often we earn interest. And this will be more like how we save for retirement, where we have a certain amount taken out each month that we put away. So here again, we're going to retire in 40 years. And in this case, we're going to be able to save $300 at the end of the month for each of the next 40 years. If we're able to invest in the stock market and earn an average of 7% per year with monthly compounding, we want to know how much we'll have at retirement. Here you see our future value of an annuity formula again. Now we'll see our inputs. Our payment or our annuity is going to be $300. Again, we know we have an annuity because all the payments are going to be equal. They occur at regular intervals and they are for a finite period of time. Our R is going to be 0.07 divided by 12. Again, in these equations, we're going to use a periodic rate, and because we're going to earn interest on a monthly basis, we have to divide by 12 because there are 12 months in a year. Our T is going to be 480, or 40 years times 12. Again, we multiply by 12 because there are 12 months in a year. And here you see the first step and our inputs, and we'll continue with this process. And as I said before, it's important to make sure that that divisor bar does not get removed if you're writing these out. So we may have a tendency just to kind of draw less and less of that line. And so we want to make sure that we don't do that. If not, you'll get the wrong answer. And in this case, we would end up with $787,444 and about 2 cents at retirement. In this case, we've saved $144,000. And we were able to earn $643,000 in compound interest over the life of this investment due to compounding. And now we're going to look at another example. And in the first two examples, we assumed that the person was going to start saving immediately. And we're going to change that assumption for this problem. So assume you would like to retire in 40 years, and we're still going to save $300 at the end of the month for all the years that we're saving. But in this case, we're going to wait to start saving for 7 years. In other words, we're still going to retire in 40 years, but we're going to wait 7 years before we make any contribution. We're still going to earn our 7% in the stock market per year with monthly compounding, and we want to know how much we're going to have at retirement. So the first challenge to this problem is to notice that we're going to wait 7 years before we start saving. It also reduces the amount of time that our first investments that we will eventually make have to earn interest. So in the previous examples, the first month that we saved, we had an opportunity to earn compound interest for 40 years. In this case, because we're waiting 7 years, but we're still going to retire in 40 years, we only have an opportunity for that first payment that we make to earn interest for 33 years. And so without calculating any numbers, we would expect this value to be lower than our previous example. Our inputs for payment is going to be the same. It's still $300 per month. Our R is still going to be a periodic rate of 7% divided by 12. And our T is going to be the amount of time that we're going to be saving or investing our annuity for. but we're waiting 7 years before we contribute. So we'll only be earning interest for 33 and investing for 33 years. We multiply that by 12 because it's still monthly compounding, and we get a value of 396 months. And so here we see our setup, and the important thing to remember, of course, is that our T is going to be 396, and we can continue with the math. And eventually our future value is going to be 300 times the quantity of 1,544.063557. And our future value is $463,219 and about 7 cents. If we look at that value and we compare it, so we take the two previous examples, we earned the same interest per month, and once we started saving, we saved the same amount each month. In the first example, we started saving right away for 40 years, and obviously in the second example, we said we waited 7 years before saving. The difference in these two account values was $324,225. In other words, by waiting only 7 years, our retirement account balance was $324,000 less than if we started saving immediately. These types of problems provide us an example of how important it is to start saving for retirement early. Even if we can't save $300 a month, the advantage that we get from saving a certain amount every month due to compounding for a long period of time is enormous. It will make a significant and meaningful impact on the amount that we have for retirement if we can start to save early.